that I am giving.
Okay.
Thanks. So today I wanted to talk to all of you guys about a project that I worked on a while ago that was basically a legacy project that we ended up having to take over as far as development goes and start actually making sure we could deploy out the project. So a lot of it was implementing DevOps on code that we didn't necessarily originally own. So this is really a lot more of a case study and a walkthrough of what we did, what we didn't do, maybe what we should have done, what worked well, what didn't work well, to hopefully help some other people in the future to maybe not make the same sort of mistakes, or maybe to be able to go down better or different paths when we're going through these sort of things. You guys all know who I am, so I'm not really going to go through the slide. If you don't, well, you can talk to me after the presentation. Fine. If you don't know who Coveros is, that is a completely different problem. I've got whoever is going, keep going here. If you don't know who Coveros is, that's another problem. Please go talk to Dave. Let him know about that. And I really, again, not something I want to deal with. So, however, what we're going to be talking about today, we are going to be talking a little bit about the project background, what it is that we started with, what we were handed with, and what our initial goals were. We're going to be talking about how we initially looked at implementing continuous integration. We're going to talk about how we expanded that to actually being able to deploy the application. Talk about a little bit how we decided on the environments that we wanted to be testing in, how we actually got the application set up in those different environments. And then we're going to talk about, of course, integrating and testing. Of course, this talk is for STPCon. DT is for testing, so we want to make sure that we talk a good amount about what it is that we actually were testing, how we verified that our application was running okay. Finally, we're going to get to some lessons learned, and then, if there are any questions, we can go through those at the end. Oh, you won't close the door, man. So, what we actually started with, sorry about that, guys. Matt just dropped food all over himself. So, as far as the company and the product, we were actually working with a company. Our client was a financial management startup company. For those of you who are not aware, this was the RE Profit Project. So, at this point, I think it was about 2 years ago, maybe a year and a half ago, that we were actually working with this company. So, they designed software that was built really to help real estate agents to be able to track their income, both against what they are making and what their expected tax reporting would be at the end of the year, so that they can spend all of their money and actually go, at the end of the year, I don't have anything to pay the IRS with, maybe I shouldn't have spent everything that I actually came in, and also to look at their ROIs, their return on their investments, so they could see if they're putting in a lot of money into marketing or a lot of money into one particular sectors, if they're getting money back. Is this a smart investment? Is this not a smart investment? The initial design, the initial implementation was all outsourced to one individual. This person did all the infrastructure work, they did all of the code design, they did all of the database design, and we inherited their interesting setup. What essentially happened with that person was their development just kind of stalled. They got about 75–80% of the way there of everything that they wanted, and for whatever reason, they were not going to be able to finish it. I don't know if it was that the particular individual was no longer capable based on some of the initial design choices they made, if they got bored with the project, if they had some sort of falling out with the company, but that was where pretty much everything stood. So this was the application then that we were going to actually end up taking over. This was a web-based application. It was a LAMP setup. I'm sorry, that's not actually accurate. It is a close to a LAMP setup, but we were using Nginx instead of Apache for our server, and we were using the Laravel framework in order to actually manage all of the code. So manage our APIs, manage our entire MVC, model. And additionally, we were using Stripe and Intuit third-party libraries in order to integrate in with the banking services and to integrate in with payment for the actual, so that people could actually sign up and register. So what was the initial project state? Now, while this talk actually does go into us being handed over a project, this is relatively typical of any time that you're going to start on a DevOps project. Well, you're going to see what is your initial state of the application, whether you're going to take over development or whether you're just going to start with the application as you have it. The code quality wasn't actually awful. All things said, there were changes that we needed to do, but not significant ones as far as the overall design. The major problem was no documentation. So everything that we were going to be doing on the application, we had to kind of dive in, read the code, and figure out what the heck was going on with the error. So, the code quality was not great, but it was not very useful and easy for us to actually take over. As far as scalability goes, the application was not designed to be specifically scalable, but due to the nature of the application, it wasn't actually an issue. We found that when we actually wanted to distribute this onto multiple machines, there was nothing that was impeding this. It just, wasn't, again, the initial purpose or design of the application. As far as security goes, everything was being managed basically as far as users and passwords with the Intuit APIs. Intuit was even managing some of the user usernames and passwords as well. There's a little bit of a risk of having everything managed by a third party, because if they, for whatever reason, got hacked, had any sort of other issue, our content that we were storing within Intuit would potentially be at risk. They had a very poor terms of service. They had some coding issues. They had some third-party libraries that were a little bit of an issue, and we'll talk about that a little bit more. Overall, the security there was nothing necessarily terrible about it, but security was definitely an afterthought. It was not something that the application was designed around. Now, being that this was a financial management application or company, and this was a financial application, you would hope that security would be paid a lot more attention to, because all of your banking information is loaded into the application. All of your banking records are being downloaded, stored in their database. And there's nothing specific that was being pulled into this particular, put into the app to make sure that this information was secure. As far as the source code goes, everything was stored in Git. So that was nice. We were able to immediately, just bring no comments. So, it didn't really help us find out too much more. The big thing that kind of killed us was there was, no testing at all. No unit tests, no integration tests, no functional tests, no non-functional tests. There's also no CI. However this application was being deployed was a complete mystery. We were basically handed a server, and we got to look at the server and figure out, all right, what was set up? How was it set up? Why was it set up this way? And basically, we got to reverse engineer how to actually go ahead and redeploy this actual application, which wasn't too terrible of a process, but it, again, wasn't ideal. They were using iWeb as their provider, something that we decided we were going to migrate away from. But again, because everything was being done manually, these are all things that we needed to build. Now, this is fairly typical for most of your let's start doing DevOps on a project implementations. You come in, there's minimal to no testing, there's minimal to no CI. So again, we're starting at a good spot starting at a spot that is fairly typical for most DevOps implementations, or initial DevOps implementations. So the approach that we took was we had a small development team. We had a tech lead, we had 2 full stack developers, and we had 1 person doing testing in DevOps. I was that person doing testing in DevOps, so that's why I'm giving you guys the talk about, implementing DevOps on this legacy system. Initially, we created a backlog in Jira that had not only development tasks, but they had a lot of infrastructure tasks as well, surrounding testing, surrounding DevOps, surrounding deployments, all of those things. We wanted to make sure that this design was a lot more security focused, and so we wanted to also make sure that we were including security early on in our DevOps pipeline and frequently as we moved through the different environments, so that we were continuously getting feedback about the actual security of the system. We set up 2-week sprints, and we went from there. The initial sprint that we laid out, our sprint 0, was mainly doing development and kind of got everything set up. So was we set up a VPN, VPCs. This, in our mind, was absolutely critical because, again, security was paramount. We were going to be having all of these machines, all these different environments up, and we wanted to make sure that no one could actually access them. This is a very common thing that I've seen on several other companies where you get in and it's, oh, how do we access our system? Well, maybe we've whitelisted some IPs. Maybe we just let everyone get access to whatever. Setting up a VPN for us was critical. There's a lot of good documentation out there as well. Definitely a good place to start so that when you start launching machines, you know that they're already protected. you don't necessarily just have to rely on username and password access. People still have to be able to log into the VPN. We ended up going with OpenVPN. We actually ended up paying $100 for a license to set something up. We could have built something for free, but honestly, in the amount of time that we had and the amount of users that we had, it actually just made more sense. It was more cost effective for us to just pay for someone else to actually host our OpenVPN server. The first thing that we actually stood up within the VPN was a secure CI machine. Everyone here better be familiar with what secure CI is. If not, I suggest you go over and talk to Glenn and ask him how you can help on the secure CI project. But the point was we wanted to utilize all the new secure CI tools. And we selected Gradle as our build tool. There was really no tasks that were currently written as far as how the application was actually being compiled is too strong of a word for PHP, but how it was being packaged and put together. And so we decided to go with Gradle. Into Gradle, we integrated in Gulp for our JavaScript management. We were using Composer for our PHP management. And we were also using PHP Unit for all of our unit tests. So actually getting continuous integration set up and moving. This was not the first way that we actually set up our continuous integration. I believe this was about our third or fourth actually iteration of slowly changing things. This is the way, however, that we should have actually set up continuous integration. Initially, we were building everything off of the develop branch. We really should have been building everything off of our feature branches. That said, we still use Gradle to drive the NPM, our node package manager, and our Gulp-based tasks in order to install the dependencies that we need, and in order to set up our database and, run absolutely everything. The next thing we wanted to do once we actually built everything, so that meant minimizing our JavaScript, setting everything else up that we needed to, was we wanted to run some unit tests. But of course, like I said, there were no unit tests. And the question was, well, how do we actually go about doing this? The method that we went with was something that actually I've used on several projects and it works fairly well. And that was any single time that you touch a piece of code, you need to write a unit test for it. If you're writing new code, make sure that you write it in such a way that it is unit testable. If you're going back and you're updating code, well, go ahead and make sure that you write unit tests for those new code, for that new code. Unfortunately, the applications we got it, and a lot of applications don't have unit tests on them, was not easily unit testable. It was written in such a way that you couldn't just start writing unit tests. We actually needed to do refactoring. So in order to make sure that we could actually do some of that refactoring, again, instead of just going out and saying we're going to dedicate a whole sprint to writing unit tests, we said every time you touch a piece of legacy code, it is make sure that you refactor it a bit and try and actually write some unit tests. We weren't perfect when we were doing this, but by the end we did have I think several hundred unit tests just from the fact of every time we touched some code, we started writing some tests. We never got to the point where we were really interested in our code coverage, but that would have been the next step. Once we had some tests written, it would have been, let's look at our code coverage, let's see what actually makes sense to start attacking as far as where we need to be writing more unit tests, where we're okay with our current unit testing. In this way, we're not wasting a lot of time writing our tests. We're also making sure that we are, in fact, attacking the places that we're changing, which is important because the application was working. We're changing something. We want to make sure that it's still going to continue to work. After that, we started adding some static analysis. We were utilizing SonarQube, and so what we did was we ran all that code through SonarQube in order to verify, well, what does it actually look like? Relatively straightforward. We ended up installing the Gradle Sonar plugin, ran things very nicely. We ended up having to install PHP SonarQube plugin. If you're not doing Java, all it means is you need to install some additional plugins. It was relatively easy to get running. Similar to our unit tests, we found that there was all sorts of technical debt, there were all sorts of issues. And instead of saying that we are going to immediately fix all these issues, we said every single time you commit code, we want to make sure that you are not adding more technical debt. We wanted to make sure that eventually we're keeping the code at the same state it was, and eventually we looked at making sure every time you check in code, the technical debt actually went down some. You didn't introduce any new issues. In order to accomplish both this and to accomplish including writing unit tests, we actually made a conscious effort when we were estimating our stories at the beginning of each sprint to include time to make sure that we could write unit tests and that we could actually potentially fix any technical debt, any issues that may pop up. It was extremely important we made this conscious effort to do that. Otherwise, we wouldn't have been able to complete everything. Or like most projects, we would have said, well, we got it working. We don't have enough time for unit tests. We'll do it later. And then that just piles up and piles up until eventually we have no unit tests and later never actually comes. The last thing we did, the last real check that we did as part of our continuous integration was we ran OAuth dependency check so that we could actually look at all of our third-party libraries that we were utilizing. We wanted to know whether there are any open CVEs, CWEs on any of these libraries to make sure that if there was, we could at least be aware of them. At this point, we were not failing our build based on open third-party library issues. We were failing it if our technical debt went up or if our unit tests, number of unit tests went down. Actually, I believe it's if our number of unit tests didn't go up. But we were more interested just to make sure that the number of issues that we had, we were aware of for knowledge so that we could look and figure out what do we need to remediate, what is okay for us to actually leave in there. And the last thing that we did was we actually packaged the app. We looked at building a few different types. I believe we ended up actually with a tar file at the end. We looked at building an RPM. We had a little bit of issues getting that into Nexus. The idea was we packaged our application, pushed it into Nexus, into its snapshot version so that we could actually go ahead and successfully deploy out this application when we needed to in one location. We were very cautious to make sure that we were not redeploying every time directly from Git, because again, PHP doesn't need to be compiled. We could just deploy out raw code. What we wanted to do was make sure that what we were deploying was the exact same application that we knew that we built, that we knew we had run our unit tests on, that we knew that we had done our static analysis on, etc. We wanted no question as to exactly what it was that was going to be deployed out onto our machines. So what did the deployment actually look like? Initially, we wrote some very simple deployment scripts. We ended up using Chef because it integrates very nicely, very easily in with AWS. So we basically had to set up and configure Nginx. We had to set up our MySQL server, and we had to make sure that we had our database set up. Because we were using Laravel as our PHP framework, we ended up using Artisan in order to manage and populate our database. So that once the database was up, we could run our Artisan command, and it would automatically generate all the schemas that we need, and it would even populate in the appropriate data so that we could seed the database with test data, or we could actually seed the database with the real data that we needed for actually running the application. So based on the environment, it was relatively easy in order to populate different data in the database. After we had all of our Chef scripts written and completed, we stood up our Chef server again inside our VPN. And then in order to do our deployment, we just used the nice EC2 plugin. Because it made things really simple. Instead of having to launch the AMI and then bootstrap and execute our Chef scripts, we can just run one command which did that all in one. Again, I can be lazy. If I can do several things in one command, I'm going to do that. And that worked very well, and that was how we initially built out our DevInt environment, with the goal of we're going to deploy out from our snapshots repo in DevInt. When we get to our later environments, we're going to be deploying out from different Nexus repos as well. So again, we deployed everything out with nice, and then what we wanted to do is actually run some real tests. And this is where we started getting some pretty good feedback. We had our smoke tests, which were done at our API level, and I'm going to talk a little bit more about our smoke and our deployment tests later on. We had our acceptance tests. They were at the UI level, and we had some relatively simple security tests. Everything was then torn down via nice, and then, well, again, towards the end, we were merging that feature branch back into develop. Initially, merging things back in develop wasn't what was actually happening at that time. And then, of course, our Nexus package was promoted out of the snapshot repository into the Next Environments repository. In this way, we made sure that each environment that we were testing had its own repository so that there was no way that I could accidentally deploy something that had only been tested in QA into production, because that had to be in the releases repository. So we had a snapshots that we used for DevInt. We had a QA repository that we used for QA. We had a staging repository that we used for staging, and we had the releases repository that we used for snapshot. And that was our basic continuous deployment method. We would spin up a new machine, we would run some sort of set of tests on these, and then we would kill the machine when we were done. It was very nice and elastic, saved us a decent amount of money, And as you can see, things didn't take that long. The deployment took the longest amount of time just for getting everything installed. Our tests, they generally took under a minute in order to get everything actually tested out. The next thing that we looked at once we had this initial deployment was, what do we really want our environments to look like, and how do we want them to be different? The model that we decided to go with, one that I really like using, is trying to, as we move through our different environments, as I mentioned, we decided on DevOps, QA, staging, and production. We wanted to make them more and more production-like. We probably could have started out with everything looking like production, but we found that we decided that there wasn't a huge point in actually doing that. There was no need to have 3 EC2 machines up in a cluster. There was no need to have a clustered database when we were just doing some relatively simple deployment, smoke, and acceptance tests. However, we did want to verify that that actually worked. So as we went from DevOps, everything running on one machine, to QA, we said we want to split off the database so we can actually test to make sure that, well, our EC2 machine and our code setup does in fact know how to reference something outside of localhost. So we're not just tied down to one database connection. When we decided to move on to staging, again, the thought was we wanted to make sure that we could actually put our machines behind a load balancer and have a clustered database. So again, becoming a lot closer to production. We figured if we can run everything on staging with 2 machines and 2 databases in the cluster, there should be absolutely no reason that production couldn't run on 3 to however many we actually needed. We never actually got to this particular point.
Max, we lost you.
Did we lose Max?
I believe we lost Max.
It's,
Well, Max seems to have figured out that he lost himself.
These comments are being recorded.
Oh,
just his phone went up.
Hey, can you guys hear me again?
Yep.
yeah, we're back. Welcome back, Max.
Yeah, well, I figured without Rich talking, they must have dropped off. So where did I drop off?
If you can run it in staging with 2 machines, then you can run it in production with 3.
Or more. Okay, perfect. So that was the initial plan. However, we never got to the point where we actually set up a clustered environment in staging. Based on where we were, we kind of, the instructions that we were going with was that it wasn't a high enough priority in order to make sure, based on the time, based on the money that it would take, to make sure that we could run something in a cluster environment. The thought was, well, based on the number of users that they're expecting in the short term, we will just upgrade from a medium machine to a large machine or to an extra large machine or a 2 extra large machine, etc., in order to face these higher potential demands on the actual system. So our staging environment never actually looked like what we wanted it to. Oh, okay. And our production environment, again, never looked exactly like that. So pretty much everything looked a lot like QA, other than, yeah, it pretty much looks a lot like what our QA did, which meant our testing was fine. However, we never got to implement all of this. We had the designs in place, just never actually got accomplished. So when we went out to actually do some of this deployment orchestration, well, we needed to re-engineer, re-architect some of our chef code to make sure it actually worked for multiple environments. The initial chef deployments that we wrote were relatively quick. As I mentioned, they were kind of hasty. And so we did have to make a few modifications. Overall, they weren't too painful, which was lucky. That was one of the nice things about the way that we actually wrote our chef scripts. But we did have to make sure that we changed how MySQL was going to connect, whether it was connecting locally, it was connecting RDS. We need to be able to pass in a parameter specifying the MySQL connections. As far as the way Nginx and as far as the way that Artisan was actually configured, we also needed to pass in different values depending on the environment that we were in. Nginx, we wanted certain logging, debugging modes turned on, so it was a lot easier to test. We also wanted different connection information, whether we were connecting to Sandbox versus production, etc. Whether we were, for Artisan, loading in test data, whether we were loading in production data, whether we wanted to seed users or not. As I mentioned before, we relied a lot on the elasticity of AWS. We only spun up instances when they were needed. We destroyed them when testing was completed. We saved a lot of money doing this, especially because we were a small development team. Even if we had been a larger development team, I do not believe it would have made a lot of sense to have a constantly up QA environment. Just would not have been a good use of time, would not have been a good use of money. So we use the AWS CLI heavily. We use it to launch and destroy our databases. We used it to create and modify our Route 63 entries. What we actually ended up doing was we bought a domain through, I believe it was GoDaddy. We tied the name servers to AWS, and then we could manage all of our different machines throughout there. And the plan was we were going to use it to create, attach, detach, and destroy elastic load balancers, and we actually got into there as well as part of our entire setup. However, when we got to production deployment, we wanted this to go a little bit differently. Again, we already knew that the application was out there, that it was running, but when we came to production, we didn't want to spin up a new instance with the new database as well. We wanted to make sure the database that was there was still up, so there was no real interruption of service. We didn't have to worry about migrating data at any point. So in that sense, our production deployment was a little bit unique, so we needed some unique scripts. We went with the blue-green deployment model. The idea was we had one production instance, one EC2 instance in our case that was up, that was connected to a database. We were going to bring up a new EC2 instance, our new server, make sure everything's installed, connect it to the same database, test that out. Once it's working, swap over the DNS settings to point to our new machine, and then shoot the old machine, because once it's all up and working, there's no need to keep the old model up there. The plan again was to do this in an entire cluster. We didn't end up going with that. We just ended up bringing up one larger machine. And, you know, the testing on it would have just been testing one machine at a time for that. And this was the overall pipeline that we ended up building as a result of all of our infrastructure that we wanted to get set up. We had our initial development test. We had our Devon's environment. From Devon, we were promoted up to QA. QA was where we ran a lot of our automated tests, and if we wanted, we could also run some of our manual tests on the QA environment as well. After QA, we advanced to staging, where we did a lot more of our long-term tests. So we ran our performance tests on there, we ran our load tests on there, we ran our penetration tests on there. And I'll talk a little bit more about what all of these tests are in the next section, actually. Once we were done with staging, then we moved on to production. So we'd actually deploy out our application. However, we didn't do any real testing on production. We just wanted to make sure that the system was up. We wanted to make sure that we weren't doing anything destructive that could potentially mess up with the database, that could impact the performance of our actual users. Now, we were not at the point that, say, Netflix is, where they want to just start tearing down machines and making sure that nothing gets affected. We wanted to keep our machines up and just fine. At this point, once we moved into production, our develop branch was merged into master, so that if we needed to make a hotfix, we knew exactly what was on master, what was on production. We didn't need to worry about any sort of potential merge issues or rollback capabilities, etc. That said, we never really finished implementing our hotfix capabilities as well, which I'll talk about a little bit later on when we get into our lessons learned. So again, this is a testing conference, or it will be when I talk at the conference. So I really want to talk about a good amount about how we integrated in testing. Because as we all know, if you have a great DevOps pipeline but no testing in there, all you're doing is you're delivering code quicker with no confidence that it's actually working properly. And well, really, what's the point in that? And I guess those go with alongside the tweets that I was making earlier this morning. So the first thing that we would do upon deploying out the application. So again, these are all on a deployed application. And we talked earlier a little bit about the testing that we did on the actual code itself. But what we wanted were some deployment tests. Unfortunately, we didn't actually have true deployment tests. So instead, what we used were smoke tests for verifying that the system was actually up. And our smoke tests were, in fact, our API tests. So because of the design of the application, there were a whole bunch of APIs that you can actually use to pretty much verify the entire workflow and the entire usage of the system. And so we made heavy use of that. Not only did we test at the UI level, we tested at the API level a lot. So what we did was we actually wrote a custom framework for our API tests. We stored the framework in Git alongside the code. This was all written in Java, and that was mainly because of simplicity for us. We probably could have written the exact same framework in PHP, generally what I would have suggested is if your developers are all PHP developers, then you should be writing your testing framework in PHP as well, because there can be shared knowledge, there can be shared code, there can be shared resources. That said, we weren't necessarily fantastic PHP developers. We could do it, but we were a bit more fluent in Java. We figured this would be the best way to move forward. So our API framework was relatively simple. Rather than using something like SOAP UI, we just wrote a few relatively easy calls that could make our puts, our posts, our gets, our deletes, and I believe that's it. So before we ran any of our actual tests, the framework would automatically make a call to our login API. After made the call to the login API, it would save off our cross-site forwarder request tokens to the system so that we could reuse those on subsequent calls. So then all we needed to do is we'd make a call, say I want to test the retrieve module or retrieve modal or retrieve count API. We could make a call to that, and we would automatically be authenticated based on the seeded user data that we provided for it. We would then get back JSON or an XML response, which we could very then easily compare. And we used the Google JSON libraries in order to make all these comparisons within there. So it was relatively easy. This was really our data-driven testing to make sure that, well, our application was up. A subset of all these API tests ran after every single deploy, and we broke out these API tests into our destructive and non-destructive tests. Because again, we wanted to make sure the system was up as quick as possible. We also didn't want to necessarily break anything with the system. So we called our non-destructive tests our smoke tests, and we called our destructive tests, well, our full set of API tests. The smoke tests were really, again, just a subset of our API tests. In hindsight, what we really should have been doing was when we were writing our chef code, we should have been writing better chef code that included unit tests and included integration tests. And our deployment tests really should have been our integration tests that were run on the actual system. And then they could say, well, is Nginx actually up? Is Nginx actually serving over port XYZ? Is the application actually installed in the right location? Are the permissions set appropriately to the application? All of these really should have been our deployment tests. But, again, that's something that we could have done that I would definitely do in the future, but not the way that we actually ended up doing this way. So we did have some nice custom reports. I understand this is a little bit hard to read based on how it is. The framework that we used was basically kind of a modified Selenium Solidified 1.x framework. If you guys aren't familiar with what Solidified is, definitely come talk to me. It's a wonderful framework for doing API and Selenium tests. Really makes things a lot simpler, but I don't want to dive into that right now. So you can see the only call that we would actually make was we'd make a call to some transaction categories, we'd make a call to some detailed subcategories, but those two off-logging calls were made automatically just as a result of the framework. I didn't need to necessarily make those calls. We would get the password, we'd get the token, we would be able to compare this information. As you can see, we'd just be comparing JSON outputs. They either worked or they didn't work. So we would get a nice pass or a nice fail based on all of those. The next thing we looked at, the next level above our APIs, we really started looking at our functional tests. For our functional testing, we wanted to use Selenium because, again, this was all on the web. It made the most amount of sense to use Selenium. We were using WebDriver, and what we were actually using was the Solidified, again, 1.x framework. So before it was really open source and made publicly available to everybody. We kept very close integration between our dev team and, well, myself, the test team, to make sure that everything could be optimally tested. This meant that we had good IDs placed throughout the application when we actually needed them, when we wanted to be able to test with them. When those weren't available, I would go talk to the dev team and say, hey, I really want to test this modal, or I really want to test this. There is no ID, can you put that in? That was fine. At other times, because of the close nature of our teams, I was actually able to go in and I could make changes to the actual source code and I could add in IDs myself. And that wasn't an issue. That is not your typical setup. Most of the time, well, most dev teams would probably shudder and cringe at testers actually making any sort of updates to the code. But if that's something you can get away with, that's great, because you need your application to be testable. And that made it really useful. Again, all of these tests were stored in Git alongside the code. So if someone were to make a change to the UI, the tests would immediately break if those tests weren't also updated. because everything was being driven by Gradle, what this meant is, as a developer, I had no excuse not to make my updates, and before I pushed anything into Git, I could rerun all of those tests locally on my own machine and verify, hey, did I break any of the tests? If I broke any of the tests, then is it something that I did, or is it something the testers did? Who do I need to reach out to? You really only get this with your more optimized development teams, but it's something that worked very well. And specifically, I think it was a little bit easier for us because, again, we were a relatively small team. We were able to execute all of these tests in parallel because, we did get to have a fair amount of tests, and we didn't want them running sequentially. So we were running, I think, about 5 different tests at a time when we were looking at this framework. That said, these were all based on the TestNG, built on top of the TestNG framework, and so we did have a lot of dependencies set up. We needed to run our add user tests, or we could run our delete user tests. And so some of these did actually some of these tests did slow down in certain areas. Similar to our API tests, these are actually broken into 2 different groups. We broke them into our acceptance tests. We broke them into our regression tests. Our acceptance tests were really our happy path tests based on our user stories. We knew what the feature was trying to accomplish, and we would write well, great, I want to write tests just for my acceptance tests. Our regression was really an expansion of these acceptance tests. How can I have my bad path? How can I have my malicious path? What about my different user scenarios, et cetera? What are all the different ways that I can do to try and break it? And this became our full regression suite based around all of these different functionalities. And sometimes there were additional tests thrown in as well. All of these tests were designed to be run through a proxy so that we could get some very simple security results at no extra cost. Again, we wanted to be very security focused with the development, with the design, and with the testing to make sure that people's usernames, account numbers, account records were not going to be exposed at any point. We wanted to make sure that just the way that we were passing data was handled properly, that the headers were appropriately configured and set up with an Nginx, that we were making all the correct calls and whatnot. So this is a nice simple output of what our functional test reports would actually look like. As you can see, these actually passed as opposed to the other failure ones. Again, it is a little bit of an eye chart, but we would launch a new browser. We would log in with our username, with our passwords. We'd wait for some things to be present. We'd go to a certain page, verify that something was actually at the appropriate value. And when we were happy with that, we could then finish our task. So the last thing that we really got into implementing as far as framework, despite the fact that this is not the last set of tests we're going to talk about, were our security tests. We ended up, as I mentioned earlier, using OAuth dependency check in order to scan our third-party libraries. We used Zap as the proxy that I was talking about earlier for our functional tests that ran both passive and active scans. Our passive scans were what we were running everything through as far as a proxy. It was basically saying and verifying that the web traffic that it was seeing, that it was not generated, was appropriate. We also ran active scans. We actually turned on Zap and we said initially unauthenticated. Well, what do you actually find with the system? We didn't want to give it credentials to be able to log in, but did you find any issues? Scan the system, find what pages you can, and identify where the issues may actually lie. We were going to try and use the Jenkins Zap plugin for authentication so that we could come up with an authenticated user to scan the rest of the system. But because the daemon doesn't actually, when you run Zap, the daemon doesn't support authentication. That said, we actually ran into some issues. Based on the way that we were setting up our XSRF tokens, we weren't able to use this relatively simple authentication setup. And so one of my coworkers actually ended up writing a specialized plugin in order to be able to handle this for Zap. And in that sense, we were able to automatically run an authenticated scan. But again, that wasn't an easy, simple thing to do, and it actually took up a decent amount of bandwidth in order to get that accomplished. As a result of all these Zap scans, an XML report was generated, but we wanted something that was easily digestible within our systems because we were very interested, again, in all of the dashboarding. All of our previous tests that were run, nice XUnit style reports were generated, and so we could feed those into SonarQube, or we could feed those into Jenkins. Well, these results, we also wanted to be able to do the same sort of thing. So with the SonarQube Zap plugin, we used an XSL to convert the XML output into something that we could actually use, and then we could feed that back into Zap. So we had those Zap results back into SonarQube, so we had all that information in one place. All these security tests, we did actually find issues. We found 12 high, 14 medium CVEs based on the libraries that we were using. These were our JavaScript libraries. These were our PHP libraries. Our security standards also came up with 38 vulnerabilities. They ranged from all sorts of things like misconfigured headers towards naming variables inappropriately, passing things inappropriately, potentially not hashed. And what we did was we basically adjudicated all of these and decided whether or not we need to address fixing them or not. And we added these to the backlog as opposed to immediately fixing most of these and reprioritized them. Unfortunately, due to the way the project was set up, most of these security things were deprioritized by the management team, the people we were actually building the project for. So we did not spend a lot of time on fixing some of the issues. Some of them we did, especially if they're relatively simple. And that actually did become an issue, and I'll talk about that when we get to some of our later tests. So as a result of something that we might have seen as far as ZAP goes, we're going to see how many high, how many medium, how many low issues. So we see some things as far as the headers not being properly set in this particular one, and what pages that actually affected. So performance tests. This was something, again, that we never actually got to. We did some initial load testing to verify that the system could come up and verify that it could actually support the users that we wanted. But initially, when we were running the system, by the time we were done with our development, there were about 20 people on it. Eventually, they wanted to make sure that it could support 100 to 500. And the thought was, when they started to notice some sort of lag on the system, they would just take whatever AMI EC2 instance size was running, they would bump it up. And they would slowly do it that way rather than us having a full understanding. It was, unfortunately, not a lot of value seen for that. That said, we did actually create some tests. We used JMeter as a proxy. We ran all of our functional tests through JMeter. We recorded all of this traffic, and then we were able to configure JMeter for multiple users and replay these back. And we did get an initial setting when we first ran through these to figure out, well, what can the system support? This is when we first took over the project. The plan was, in addition to our load testing, so can it support the load that we expect, to do some stress testing. At what point does the system break? This was where we never actually got. The idea was we wanted to take our API tests as they were reported, run them through Load UI and Soap UI so that we could really do some good stress testing of the system and basically ramp up more and more and more until we started getting 500 errors or until we started getting 400 errors so that we couldn't get anything back from the actual system. We wanted to generate a load to actually cause the system to break. There was never any plan for these to be an automated gate within our pipeline. Everything else that we were talking about up to this point, if the tests failed, well, we would fail our build, and the application would never proceed past DevEnt or QA or staging, wherever it was we actually saw this failure. For performance tests, we wanted to be aware of what these issues were, and then we
Please stand by while we solve some technical communication problems. We believe we lost Max again.
Does he know he got dropped?
So as we wait, Gene is texting Max. I pinged him on Slack. He's on a roll. We're trying to get Max's attention with a phone call this time.
You know, I almost thought of just ignoring Gene's call, wondering why the hell he was calling me. But
Why are you people bothering me?
all right, so you
back.
lost me at penetration testing. Is that it?
What was the slide right before it?
Oh, so you lost me at performance testing.
Maybe. And then what's after? What's 27?
So this picture.
Yeah, you were on this.
Yep.
All right, great. These are my performance testing results. As you can see, we added more users. Our load time increased. It's kind of what we expected. We were able to get about 200 or 300 users actually through the system without anything breaking. So penetration tests. This was another thing that we never actually got to accomplish. However, we did have an outline to use W3AF as far as looking at the actual application on the system and using OpenSCAP in order to actually scan the system and make sure that it was appropriately hardened. Unfortunately, due to budget, due to priorities, we never actually implemented all of this. The system, of course, was designed so that even if anyone did get access to any one part, you know, they wouldn't really have access to anything else. They couldn't get into our databases, etc. That said, well, because we didn't do our penetration tests within about a month or two, maybe a little bit longer, we noticed that one of the boxes that we had set up for our client actually got rooted. We still don't know 100% of the cause. It could have been a little bit of poor password management. It could have been some open vulnerabilities in old applications that were running on the box because, again, these things were not being upgraded, and we weren't doing a good job of keeping track of the latest vulnerabilities that are out there on all of these different boxes. Had we been running our penetration tests regularly, we would have identified that immediately and been able to resolve this. But we honestly don't know how long someone had access to that box. There was no critical data at all on it. Luckily, we had snapshots, we were able to roll it back. However, that put us in the fun position of having to explain to our clients why their box was rooted, how it was rooted, and why we weren't able to catch and fix this. And just because it wasn't a high priority is usually not a good excuse. You want to go back and tell the client, well, it's your fault. Additionally, we had to spend additional time and additional money to actually fix the problem and to then go ahead and harden the system. Since then, I'm sure no one's actually looked at it, and hopefully that same issue hasn't actually happened. But again, without these penetration tests, things that we weren't able to do, we weren't able to verify that things were actually working appropriately. So a few lessons learned. As we were going through, I've already talked about several of these, but one of the big things was, other than DevOps, which was triggered immediately after a build was completed, all of our different environments were actually spun up kind of based on timing. So QA was run every 6 hours, staging was run every day, and we deployed to production about every week. And the thought was, because we thought our staging test may take about an hour, and our QA test may take up to an hour, and our stage test may take several hours, we didn't want them running back-to-back on every single build because, well, it was going to potentially have things start backing up if I made 10 commits in an hour. Well, joke was kind of on us. We weren't developing at that fast of a pace. We could have just killed extra builds and only built with the latest one that made it out of our particular build. And as a result, we actually ended up having to spend more time, more effort, and really just ended up delaying our deployments more than anything else. Our UI tests were a little bit slow. We ended with about 700-ish Selenium tests. Took about almost an hour to run absolutely all of them. Had we used something like Selenium Grid in order to distribute these on multiple machines, really make great use of parallelization, we could have drastically reduced the feedback cycle. We never got to implement a hotfix pipeline. I don't believe that was ever really a problem for us. But again, it was a small development team. And in my mind, we kind of got lucky that we never pushed anything out to production that was critically terrible. Do development for a long enough time, we absolutely would have run into that problem, and then we would have been scrambling to get that done. As I mentioned, there was not a huge focus on non-functional testing. We did some security things, but again, we did not do a lot of performance. We did hardly any penetration, and we definitely should have devoted more time and resources towards that. Chef Server, in my opinion, was overkill for what we were using. We probably could have gotten away with Chef Solo or Chef Zero, and used that in conjunction with Kitchen in order to make sure that the exact same way that people were testing out their deployments locally, we could deploy out the exact same way. For this small development, with the number of machines that we managed, Chef, not that it added more complexity, but it was another machine that needed to be managed that cost us money that we probably could have done without. And so with that, now that I've spoken about most of these slides at least 1.5 times, concludes my presentation. If you guys have any questions, comments, that you didn't want to voice before, I'd love to have a quick discussion with our remaining time. Rich, this